In this video, we are going to talk about inverse Z transform. In our last video, we have learned how to calculate Z transform for some of the sequences. In this video, we are going to talk about how we can calculate inverse Z transforms. So before going to the problem, we have to remember these three rules. So Z inverse of Z by Z minus A is equal to A power n. Because we know that Z transform of A power n is equal to Z by Z minus A. So if I want to calculate Z inverse, then we have Z inverse of Z minus A is equal to A to the power n. We have already learned Laplace. In Laplace, L of f of t, that is going to be equal to f of s. That means a function is given which is in terms of t. If I apply Laplace, I will get the answer in terms of s. Then if I take L inverse of this function f of s, then what I have, L inverse of f of s is equal to f of t. That means the function which have s, if I apply L inverse, then this would become a function in terms of t. The same thing here. If I apply Z transform of the sequence with n, then I have z in the answer. If I apply Z transform of this function, then the answer will be my sequence with some power n. So the rule number 2, Z inverse of Z by Z plus A, that is nothing but minus A the whole power n. So if you see this formula, you can easily remember. If the denominator has a positive sign, that is plus A, then you have to take the opposite sign with power n. If the denominator has minus sign, then you have positive A to the power n. Okay, finding Z transform is not that much difficult. It is very easy. You have to remember the steps, the following steps before applying inverse Z transform. So we are going to follow 5 steps to calculate Z transform of a given function. Step number 1, we have to take the function, the given transform as f of z. Step number 2, we can collect some z from the numerator of the given function, or I can say divide f of z, that is the given transform, by z. In step number 3, whatever the result f of z, you have to consider this result and we have to apply partial fraction. Step number 4, in step number 2, we divide the function by z. In step number 4, what we do, we are going to multiply the result of the partial fraction by z. That is both left side as well as right side. And finally, we are going to take inverse z transform. That will conclude the problem. Let us see question number 1. In question number 1, what is given? Z transform of 2z power 2 plus 3z upon z plus 2 times z minus 4. So as per step number 1, we consider this as my function, that is f of z. So f of z equal to whatever given in the problem, you just write it. Then step number 2, we are going to divide f of z by z. Instead of that, if you see the numerator, you have 2z squared plus 3z. Okay. If I take z as a common term, then we have remaining with 2z plus 3. So this one I write it here. Then divide both sides by z. So this will become f of z by z. Here z get cancelled. Or you can think like this also. This z, if you take down, it will be f of z by z is equal to 2z plus 3 divided by n z plus 2 times z minus 4. Then step number 3, we are going to apply partial fraction. So how to apply partial fraction? We consider only this part. So we have 2z plus 3 upon z plus 2 times z minus 4. If you see the denominator, I have two linear factors, z plus 2 and z minus 4. So I can write a by z plus 2 plus b by z minus 4. Then we have 2z plus 3, that is equal to a times z minus 4 plus b times z plus 2. Now I am going to calculate the value of a and b. For that, I am going to put z equal to 4. If I put z equal to 4, the left hand side becomes 2 times 4 plus 3 is equal to, if I substitute 4 here, I will get 4 minus 4, that is going to be 0. So we have remaining with b times z plus 2. Replace z by 4, I will get 4 plus 2. So 2 times 4 will be 8. 8 plus 3 equal to 4 plus 2 6. So we have 6b. So I can say 6b equal to 8 plus 3 11, or b equal to 11 by 6. Next, to calculate a, I am going to substitute z equal to minus 2. So if I substitute minus 2 in this equation, I will get 2 times of minus 2 plus 3, that is equal to a minus 2 minus 4, the term b will get cancelled. So we have minus 4 plus 3, that is equal to minus 6a, or I can say minus 6a equal to minus 1. So a equal to 1 over 6. So we will get b equal to 11 by 16 and a equal to 1 by 6. Now let us substitute a value, b value in the respective places. We will get this one, 1 over 6 by z plus 2 plus 11 over 6 divided by z minus 4. Now step number 4, we are going to multiply both sides of this equation by z. So that means here we have z, here we have z, here we have z. These two get cancelled and this 1 by 6 will take outside. From the second term, take 11 by 6 outside. So we have 1 over 6 z by z plus 2 plus 11 over 6 z by z minus 4. Okay, so still we need to calculate z inverse. So let me take z inverse for this. So this would become 1 by 6 z inverse of z by z plus 2 plus 11 over 6 z inverse of z by z minus 4. So we have 1 over 6 z inverse of z by z plus 2. So this is nothing but, what is the rule? Z inverse of z by z plus a, that is equal to minus a whole to the power n. If it is plus, this would become minus. So here we have plus 2. So I can write minus 2 to the power n plus 11 over 6 for this one. Z inverse of z by z minus 4, we have plus 4 power n because we have minus 4 in the denominator. So my final answer is 1 over 6 minus 2 to the power n plus 11 over 16, 4 to the power n. Let us do one more problem. Here we have to calculate z inverse of z power 2 minus z divided by z minus 2, z minus 4, z minus 6. So step number 1, we consider the given function as f of z. Then from these two, let me take z as a common factor, we'll have this. And as per step number 2, we divide this by z, we will get this. Step number 3, we are going to apply partial fraction. In this problem, I have 3 linear factors. So here we have, this is like a, b and c. So let me write this as a by z minus 2 plus b by z minus 4 plus c by z minus 6. Then we have this one, this equation, right? When you take a, you have to multiply by z minus 4 and z minus 6. When you take b, you have to multiply by z minus 2 and z minus 6. When you take c, you have to multiply by z minus 2 and z minus 4. Now by putting these values, let me substitute z equal to 2. That will give you a equal to minus 9 over 4. If I put z equal to 4, we will get b equal to 4. And finally, if I substitute z equal to 6, I will get c equal to minus 7 over 4. So now in place of a, in place of this a, we will write minus 9 by 4 divided by z minus 2. In place of b, we will write 4 divided by z minus 4. In place of c, we have minus 7 over 4 divided by z minus 6. This side, left side, is nothing but f of z by z. So we have f of z by z equal to this. Now I want to cancel this z. For that, I am going to multiply both sides of this equation by z. So if I multiply by z, what I will get? Here we have z, z here, and z here. Okay. So I will get this one. So from the first term, let me take minus 9 by 4 outside. So if I take minus 9 by 4 outside, the remaining will be z upon z minus 2. From the second term, let us take 4 outside. If I take 4 outside, remaining will be z by z minus 4. From the third term, if I take minus 7 by 4, we have remaining with z by z minus 6. Then in the last step, we have to take z inverse of this, z inverse of this, and z inverse of this. So the final answer is going to be minus 9 by 4. This z by z minus 2 is nothing but 2 to the power n plus 4. Here we have z by z minus 4. So it's going to be positive 4 to the power n. Then we have minus 7 over 4. In the denominator, I have minus 6. So this I can write 6 to the power n. So my final answer is minus 9 over 2, 2 to the power n, plus 4 times of 4 to the power n, minus 7 over 4, 6 to the power n. Try these problems. See you in the next video.